Hello and a warm welcome back. Today on the bench we've got a couple of EL84 monoblocks. They use two EL84s, an EZ81 for the rectifier and an ECF80 for the voltage gain stage and cathode phase splitter. These are from Ian again, our friend Ian, over in down south. He didn't make them, he bought them some time ago and just wanted me to run my eye over them and see what I thought. As you can see, the power transformers, rather big ones, they look quite substantial. Couple of smoothing reservoir caps, and then these are the output transformers. The output transformers don't look brilliant, but then again they may be alright. They look quite old ones, being wound without a bobbin and using paper insulation. Let's have a look underneath. As you can see, there are some differences. We've got a couple of big chokes there on each one. This one smells of burning, and we've got this bit of insulation here that sort of come loose, missing. And as you can see here, the resistors here are different to those ones there. There's a few caps that are different, but overall they're the same. There's a few other changes, like the one side has got a different main switch to the other, and this one is fused here, whereas this one has a panel fuse on the back which you can't see. I back engineered them, or whatever you call it, worked out the circuit. I found that I didn't really need to, because I did found a schematic online which is essentially the same as this. However, working out the circuit yourself does reveal and show you a lot of things that the schematic doesn't. So essentially what we've got the pentode of the ECF80 configured as a high gain voltage, high voltage gain stage, all pretty straightforward. And then we've got the triode section configured as a cathode phase splitter. As you can see, two equal resistors of we've got an anode resistor of 47k, cathode resistor of 47k, and this 2k2 there is to bias it at the correct voltage. And then we've got the EL84 push-pull output stage. The figures in green are the differences between the schematic online and the one that I lifted off here, using the values that I lifted off here. As you can see on this, we've got 270 ohm cathode bias resistors for the EL84 stages, and I've just noticed I haven't drawn the decoupling cap. There's a couple of 47 mic decoupling caps on there that I haven't drawn. There is another disparity with the grid stopper on the pentode stage having a higher resistance than the one on the schematic that I found online. The power supply is pretty straightforward. We've got a centre tapped secondary, goes into our EZ81, and all these capacitors are 50 microfarads each. So we've got the first reservoir capacitor that feeds the output transformer. The second stage there feeds the screen grids for the EL84s, and we've got the choke in between. I don't know what value the choke is. And then we've got a couple of RC filters there, dropping the voltage down as we go along and hopefully reducing ripple. Some of these values are only tentative because some of the resistors, after they age, the colour bands lose the colour and it's a bit hard to figure out what they are. But yeah, essentially straightforward. However, I did make a cock up here. The secondary of the output transformer has got a Zobel network across it. That should be the other way around. The resistor should be there on the ground side and the capacitor there. One other difference is that one of them had been modified and had this little circuit on there. I wasn't sure whether it was a constant current source or sink or whatever or something like that, but in the end it turned out to be pretty straightforward. It uses an EL150 high voltage depletion MOSFET, and it's just configured as a boost circuit. Really, it just boosts the voltage going into the pentode stage of the ECF80. Yeah, so as you can see, we've got a couple of back-to-back zoners there protecting the gate source, although I would have thought of that would have been connected there, but not to ground. But there we go. Yeah, pretty straightforward. Construction wise, it's pretty well built. Only minor niggle on my part is that it's using black wire all over the place, which it basically makes it hard to work out where everything goes. So, you know, I had to use me beeper on me multimeter to just buzz out the circuit. Yeah, it's, you know, pretty well built. The only sort of minor niggle I've got really is that instead of using the star ground going to here, which is our main sort of grounding point, different parts of the circuit are grounded direct to the chassis. This is the sort of thing you find on a guitar amplifier. Yeah, so here we've got the filament, each winding, blah blah blah, humdinger, humbucker, sense tapped, the grounded, that's grounded to the chassis there, same as this circuitry here, it's grounded to the chassis there, pretty much the same all over. This isn't usually a good idea because it can create ground loops create hum, so we'll see when we power it up. So the first thing I'm going to do is to power it up on the lamp limiter variac, have a look at what the voltage of the transformer is by sticking a couple of probes on there on the EZ81 valve base. 275, so we're cushy there. Let me just move the other one, turn the power off. When you're fucking about with mains, best to be safe than sorry. Live to fight another day, as they say. 275. Obviously that's going to drop on load. So the next thing to do then is to put the EZ81 in, but we need to reduce the mains a little bit because obviously it's not loaded. So I'll do that and we'll see if we've got any DC coming out, and hopefully that should tell us whether the choke's any good or not. We've got one EZ81 in, except it isn't a EZ81, it's a 6CA4, which is more or less the same thing. We're not at full mains. The capacitors are 500 volt rated, so should be okay. Got it on the lamp limiter and the variac, and we're about at 240 volts mains voltage, and we're reading 334 volts. Everything seems fine, nothing's gone bang, and I can't hear any buzzing or anything like that. Kill the mains, and that should now come down. One thing there isn't across the capacitors, which I noticed, was a drop-in bleed resistor. But I mean, with the valves remaining warm after powering down, they should drop a lot of the voltage. It's coming down quite quickly. A word on powering amplifiers up. If you've got any bit of kit you know, be it valve, transistor or whatever, and it's not been powered up for a long time, you don't want to just go and power the thing up straight away with full mains power, with full mains voltage. There could be things damaged in there. All sort of things can occur if you do that. You can end up creating a lot more damage. So before powering up anything, build yourself a lamp limiter. It's just a couple of light bulbs that you switch in. And the other thing is, a variac is also good, but a lamp limiter is essential. And obviously, give whatever it is you're powering up, take the top off, have a look inside, see if there is any damage. Also, check the fuses. I have found a 6-inch nail once in a, I've got a big HP spectrum analyzer underneath there somewhere. And as I said, I found a big 6-inch nail as the mains fuse in there, and as a result that burnt out one of the mains transformers. Luckily I was able to find another one, but yeah, that sort of crazy shit is what you're looking for. The other thing that you usually find is in the UK we've got a fuse in our plugs, and you find a lot of the times that it'll have a 13 amp fuse in. It's not needed. It looks like somebody switched on here and put a 2 amp in there. It's probably, I don't know, but yeah, you should always have a look at things like that. The next thing we're going to do is put all the valves in, power it up slowly, and then do some DC condition testing and see what we get. The valves are all in. We're still on the lamp limiter, so I'll power it up. It's going to take a while for the HT to come up. Right, I've measured the DC condition voltages. Everything is pretty cushy and normal, apart from we are getting, where are we, pin 2. It's a bit hard to find out where I'm going, so it's a bit hard to try and get you so you can see this. So as you can see there, that's the grid, control grid of one EL84 0.02 volts, and this is the control grid on another one. And again, I'm going to have to be a bit of a contortionist. I don't like holding the probe in the left hand because you should always hold it in the right. Okay, you see there, look, that's the control grid of the other one, 8.4 volts, and that is this capacitor here. On one side 82 volts, on the other side 9 volts. Do the same this side, yeah? This is the anode side of the triode, 153. So it looks like we've got a leaky cap there. Earlier on I was trying to get a VGK reading of the triode on this ECF80 valve here, and I was getting crazy readings. I got something like, where are we, let me just look at my notes. Oh yeah, cathode 80 volts, control grid 51 volts. Well, that's bonkers. That would mean like a VGK of 30 volts ish. But you can have this when you measure the control grid voltages of valves. Because the valve is a very high impedance device, the control grid is very high impedance, and your digital multimeter can affect the reading of that when you go to measure the control grid, because it's such high impedance. Even if your multimeter has got something like 10 mega ohm what do you call it, resistance, is that right? No, 10 mega ohm impedance in it, you know what I mean. So that needs looking at. What else needs looking at? Towards the end of the first test, some things were getting hot and there was smoke coming out. So there's some things of note that I noted before. These cathode resistors here are really small, they're really diddy, they ought to be bigger than that. These grid resistors, they're a bit diddy too. Obviously this capacitor here wants changing out because it looks like it's leaky. I've changed those two components that I mentioned, the cathode resistor on one EL84 and the decoupling capacitor. That's just tacked in for now, that's all I've got at the moment. And the cathode voltage now is 11.5 volts, which is a lot better. Got some AC going in. This is 100 hertz at the moment. As you can see, it's not brilliant. If we have a look at the readout on the audio analyzer, it's 5.6 volts, which is, yeah, not much. Well, let's just see what that is. For what? Which is pretty bloody useless. Let's change the frequency. That jumps to 6.4 volts, or let's see if we can get a bit more out. No, you see it's starting to get crossover. Right, 6 volts. Oh, sorry, 6 watts at 1 kilohertz. Oh, sorry. Frequency. As you can see, at 10 kilohertz, that's starting to distort badly. 4.6 volts RMS, and that's pretty bloody useless. Just knock it back to 1 kilohertz. Okay, that's full output power. Distortion is 1.4%, 7 volts, 3% THD. So, all in all, not very good. We need to have a think about this. To try and get to the bottom of why these amplifiers aren't kicking out full output power, I'm measuring the output transformers to try and find out what their specifications are. So what I'm doing, I'm putting a 1 kilohertz sine wave in through the primary and then reading what we get out on the secondary. This is all without any loads. We've got 1.985 going in, 0.88 volts coming out. That looks like that's on the 4 ohm tap. On the 8 ohm tap we've got 0.128. So now we'll do the calculations. Right, so we've got two problems. We've got a issue, I think, with the output transformer being not the right one. I've done the calculations two different ways. I did it with taking the anode voltages before clipping and the output voltage and using those figures to do the calculation. I also used a signal generator off the audio analyzer, did it that way and got more or less the same answer, which was a primary impedance of 2k, which is too low. It should be about something about like 6k6 is the traditional EL84 primary impedance. The other problem we've got is that we have a positive DC voltage on one of the EL84 grids. I've changed out, if you can see this resistor here, I changed out this coupling cap. I mean, these are really reliable components, they don't usually go. That sort of solved the problem, and for what, 10 minutes, and then we've got a positive voltage back on here again. So now I'm going to do a quick substitution test. I'm going to switch it on, take some readings, swap the EL84s and see if the problem follows the valve. Just switched it on. We've got about 330 volts HT. As you can see, the control grid in question has a voltage of 0.6 16, sorry. The other one is less than that. The other cathode is about 11 volts. This cathode on the one, the dodgy one, is about 11 volts. Let's call that 12 volts. There we go. 2.7 volts on the other one. Still less than 1 volt. So it could be the valve base, or it could be the capacitor leaking. Let's change the capacitor out again and see if that makes a difference. And then, no, hold on, or shall we swap the valves? I think we'll swap the valves first and see whether that makes a difference. I'll quickly swap the valves. And as you can see, what the? Hold on, that was the anode, sorry. Put my probe in the wrong place, as the actress said to the bishop. Right. So it's definitely either the base or the capacitor or something. I will change the capacitor and see if that helps. Well, I've changed that capacitor for another one. And as you can see, we've still got the problem. So I think it's the valve base. So what I'm going to do, I'm just going to touch my probe on the valve base itself. What the? It's a puzzler, isn't it? Oh, I've got that clipped on now. The other side of the grid stopper. As soon as I move that, I'm moving the pin around with a wooden probe thingy. See, that's changing, isn't it? I'll clean the valve base up and see if that makes a difference. I don't know if you can see that on camera, but this valve base here is very greasy. About running out of this stuff. Give that one a clean while I'm at it. The other thing is, I don't think you'll be able to see it on camera. See if I can zoom you in. Is it liking that? I don't think it is. It has tuning fork, what we call tuning fork pins. I'll show you on a piece of paper. So there's two basic types of pin, valve pin thingy. The ones I'm on about here are these what we call tuning fork type pins, amongst the fraternity of artificers and vintage valve techs. So I've got a doodah like that. Actually, yeah, that's right. And then there's sort of like a bit like that, something like that. Really badly drawn, you get the gist. And then there's this other type, which is like a cup type. Which is more like a, what would you call it? More like a tube. Obviously that's bored out in the middle there, and that's your pin. So these type, I think the Murdo type, not very good. This is one with those sort of cups, as you can see. So I've cleaned it up. We'll see if that works. If not, we're going to have to change the valve base out. We'll see how we go. As you can see from the reading, that doesn't seem to have fixed the problem at all. 12.5. See, as the control grid goes more positive, more current will flow through the valve and thus through the cathode resistor, and so what the valve will try and do, or the circuit will try and do, is to compensate for that positive voltage on the grid by making the cathode more positive. More current flows through the cathode resistor because of that voltage on the control grid, so it's trying to compensate. But I think there comes a point where it just can't compensate anymore. So to recap, where to go, what to do. I could try and fix the, I think it's a valve base issue here. That can be the only component that we haven't tried changing. But even if I fix that valve base, then we still have the problem of the low primary impedance of the output transformers. These amplifiers will never make, I don't think, although we haven't tested this one yet, I don't think they will ever make 10 watts. Does that matter? Maybe not. The other thing we haven't done is to give them a listening test to see what they sound like. So there's still quite a bit of investigation and probably a bit of consultation with Ian to see where he wants to go with these. Probably they could do with the output transformers changing, but I don't know. Whether he wants to go down that route, I don't know. This circuit, I basically started a thread on a forum that I'm on, and the circuit has been around for quite a few years, so I mean it does work, but in this case it doesn't seem to be. We're gonna have to cut this one here because the video is obviously getting on a bit. You may have noticed that the video looks different and the audio is different. That's because my old camera died. Ian kindly gave me another camera which I'm not quite used to, and so forgive any sort of weirdness with the video itself. Right, well, thank you all for watching. Take care of yourselves. Ta-ra for now.